Thank you, Mr. Chairman. Ladies and gentlemen, thank you once again for the hospitality which I discover every year here in Belgrade, and especially to our friend from KGA. In the name of Romanian Building Services Association, in the name of our president, Professor Liviu Dumitrescu, I want to wish you all the best. I come in the front of you with work which started 1 year ago, from 2.5 years, because I travel a lot in Brussels, according with my duty like vice president. I start to work with my company in Brussels, and I want to come in the front of you with an example which could be because that show how you can implement the really eco design, because we speak about eco design. We speak also about passive house, and my presentation will show you that. In Brussels region exists an exemplary building organization which is in charge to control the new buildings, and also they can give subsidies to the project if the project respects the design until the end when the house will be put in function. In fact, what is an exemplary building? An exemplary building is a building that has remarkable solution to a series of criteria regarding sustainable building, and this is in a larger sense than just energy-related questions. Thus, an exemplary building is made to be more energy efficient, passive standard, present the lowest environmental impact in the wide sense of the term, construction, use, demolition. Ensure an exemplary comfort, visual, thermic, acoustic. Ensure a good water and waste management. Encourage biodiversity and on the site. Have a great architectural quality and use a reproducible and profitable solution. How you can see, the school, I will present a nursery and a primary school of 750 pupils, a special shape situated in Anderlecht, Brussels. The area of this school, it's 9,100 square meters. There is four buildings in the shape of circle, and a sport house. Sorry, how you can see, and a sport hall. Sorry. How I said before, something specific characteristic, some specific characteristic of the building. The global U values is 0.18 watts per square meter per kilowatt. Double flux ventilation with Canadian well. We have cogenerations at 6 kilowatt from electrical part and 11 kilowatt for thermic part in the sport hall. Sun protection, free cooling and night cooling, bicycle parking, green roof and facade, gardens, fountains, green semi-intensive roof, rainwater tank 40 cubic meters, retention basins, building site waste sorting, and walls ceiling with acoustic isolation. In passive terms, we are with the school at 9 kilowatt-hour per square meter per year for the school, and 7 kilowatt-hour per square meter per year for the gym. How you can see, we are nearly zero energy building with that building. In fact, in that stage, I can assure you we are at 11 kilowatt-hour per square meters per year with the both building. That value which I presented, it was in the start of design. Architecture and installation. The daylights. As an important contribution of the daylight, independent from the artificial lighting during the school hours. The daylight factor in the classroom is more than 5%. The daylight autonomy in the classroom is of 80%. High performance thermic isolation. The floor isolation, 130 meters expanded granulated with a value of 0.78 watt per square meter Kelvin. The wall isolation is glass wall at 36 centimeters, the value of U 0.097 watt per square meter Kelvin. Roof isolation, polyurethane, 30 centimeters with a value of 0.09 watt per square meter per Kelvin. Carpentry isolation, 0.8 watt per square meter Kelvin, and UG is 0.6 watt per square meter Kelvin, triple glazing. The air tightness, it's an important issue. All constructive notes have been detailed and simulated with the help of a program to ensure the perfect continuity of the installation and of the air tightness barrier. It respects the norm N50, less than 0.6 volume per hour. Concept for installation. The heating. In the school, the heating plant is with condensing boiler. The heating, it's independent of ventilation to ensure an optimal thermic comfort of the internal and external intake in the classroom. The ventilation is with free cooling and night cooling in order to ensure the thermic comfort in the summer validated by the dynamic simulation. Heating in the classroom is with the radiators to have a rapid reaction of the system. In the hall we have floor heating. The gym heating plant is with condensing boiler and cogeneration, and we change now the systems with the displacement ventilation required in the gym hall to don't disturb with the flow with a big speed to don't disturb the activity in the sport hall. Regarding the electrical, the school is high-performance lamps with the electronic lamp, electronic ballast, artificial lighting management through light intensity and movement sensor. The gym has two levels of lighting for training and for competition. And of course, the building management system of the building is we can find at this project. Concept for installation regarding the sanitation facility. The production of domestic hot water is with condensation gas boiler and in the school, And for the gym hall, the domestic hot water is producing cogeneration. We can see here the scheme, how we produce also electricity and domestic hot water with the cogeneration system. The monitoring, it's an important issue, and it's dedicated to verify that the functioning of the building remain compliant to the initial concept. The monitoring of the building installation is done by electric meter for each electric panel, electric meter for each HVAC device, meter with heating integration for each heating circuit and the cogeneration, impulsion meters to measure the gas and water consumption, consumption panel of the entire site on the property. We have here an image section in the building, the hall with the air handling units, the class with the triple glazing systems, and the heating system is with radiator. And also you can see the isolation of the ground floor and on the roof, the system, how it's isolated, the building. Some pictures from the hall where we have floor heating and air handling units for each classroom. I want to mention there is 60 classrooms. Each classroom is ventilated with air handling units. The concept for the ventilation, a double flux high efficiency air handling units for each classroom, automation of the airflow with the help of temperature and CO2 sensors, ventilation through free cooling and night cooling for a thermic comfort during summer. The quality of the interior climate comfort is paramount for the health and the performance of the pupils and children. For each unit, we calculated the pressure drop, which is very important. Finally, you will see, I will show, we calculate the final drops, we calculate the efficiency of the heat exchanger, we calculate the noises to cover, in fact, the requirements of standard 15251, European standard 15251, who define the parameters for design in the school. We can see for a floor air at 830 cubic meter per hour, the pressure drop from one unit, which is an example, we have from supply 69 Pascal, and for extractions 61 Pascal. In that way, we choose the air handling units, which is a Svegon and air handling units for each classroom, with a high efficiency for the heat exchanger at 90%. Taking in consideration the nominal condition at -8 degree, outside temperature, 20 degree inside temperature. Also, it was related the efficiency in accordance with the standard EN 308. And also taking in account the engine of the fan. An important parameters which we should prove measured on site was the specific fan power characteristic. Also for the each fan from supply and for extraction. In fact, what we have here in the table, it's the calculated specific fan parameters, which is 684 for supply and 720 for exhaust. The condition was to be in the class 2, less than 750 watt per cubic meter per second. Finally, it was imposed to be measured, to be checked for a neutral organism from Brussels, and we obtain less than that value because of the fee, which in theory it's 0.070, and in measurement it was 0.62, 0.63. An important thing was also to the noise characteristic, and taking in account the noise value, we make the calculation for the noise to calculate the sound dampers for each air handling unit, having in final in the classroom 35 decibel the noise, which was requested and is according with the standard 15251. There are pictures how we measure on site, because they ask us to have a mock-up classroom to show that all what is done in accordance with the exemplary building. And finally we succeed, and we expect in February to be open this school. Thank you very much.